All right, I didn't mean to make 2 videos, but I guess 20 minutes of lesson is not that bad. Keep in mind, again, those last ones were mostly focused on pre-calculus concepts, just making sure you can solve an exponential when you're looking for the variable in the exponent or by subbing into the exponent and solving for the value at the end. This next thing we're going to talk about real quick is called Newton's law of cooling, and it states that the difference meaning subtraction, between an object's temperature and the room temperature decreases exponentially with time as the object cools. So this is really our setup. We now no longer just have y equals c e to the kt. We have to take into consideration the room temperature of the object. So the easiest way to think about this is if you were to take a pizza out of the oven and put it outside on a freezing cold day, okay, the freezing cold temperature around it is going to make that pizza cool a lot faster than if you took the pizza out of the oven and then just set it on top of your already warm oven and let it sit there until you were ready to eat it. Okay, so we need to take into consideration the room temperature when figuring things out. This is also a little morbid, but this is how they figure out the temperature. They use the temperature of a dead body to figure out what the time of death was. And unfortunately, we aren't going to have class, but we did an activity in previous years dealing with solving a murder mystery, and maybe we'll try to throw that in. Mr. Lakin, I'll run that by you soon. All right, last example. As a part of his summer job at a restaurant, Jim learned to cook up a big pot of soup late at night just before closing time, so there'd be plenty of soup to feed customers the next day. He also found out that while refrigeration was essential to preserve the soup overnight, the soup was too hot to be put directly into the fridge. This is the same idea of if you make pasta salad and you put the hot pasta into your refrigerator, the temperature of your refrigerator will go up because if the pasta is too hot, it is actually heating the environment as opposed to the refrigerator cooling the things around it, and you can end up spoiling food. So be careful. The soup had just boiled at 100 degrees Celsius. So we have our initial soup is 100 degrees Celsius coming off the pot. And the fridge was not powerful enough to accommodate a big pot of soup if it was any warmer than 20 degrees. So we need to figure out how we can get our soup to get down to 20 degrees so we can put it into the fridge. Looks like he is a good scientist and he took some other data. He could bring the temperature of the soup to 60 degrees Celsius in 10 minutes. So after 10 minutes, we're down to 60, which is great. And I skipped over this part, and I should have. Our temperature, we're running it under cooled water of 5 degrees Celsius. How long before closing time should the soup be ready so that Jim could put it in the fridge and still leave on time? So picture he's going to take the soup off the burner. He's going to run it under this cold water until it eventually gets down to 20 degrees Celsius so that he can safely put it into the fridge and be ready for the next morning. So we got to use our new equation, y minus r is equal to c e to the kt. We have our initial condition of 100, so 100 minus 5 is equal to c e to the k times 0. So 95, this little 1, is equal to c. So moving along, I'm going to get y minus, that 5 still has to be there. 95 is now my c value. E to the kt. Still building out my equation, I'm going to use that very scientifically researched data point that the temperature was 60 degrees after 10 minutes. So watch how I find k. 60 minus 5 is 55, divided by 95 is equal to e to the 10k. I'm going to take the natural log of both sides. Come up here. And then divide by 10. So the natural log of 55/95, whatever that is equal to 10k, technically times the natural log of e, but that'll be gone. So 1/10 natural log of 55/95. Now, you can round this in your calculator to be approximately negative 0.0547, but I would store that as something in your calculator so you don't have rounding error in between. Okay, so the last thing is we want to figure out when will this whole thing be equal to 20. So 20 minus 5 is equal to, we said our initial value was 95, e to the 0.0547 exponential decay, and we're looking to solve for t. So go ahead and take a second figure out what t is equal to. We're going to round to 3 decimal places. So I'm going to help you get started. We're going to have 15 divided by 95 equals e to the negative 0.0547547 times t. Take a natural log of both sides. T is approximately, and I'm actually not going to leave the answer here because this is in our quick check for the attendance today. This will be your one math question that you have. Please make sure that you've done your AP classroom assignment before you go do that attendance check. That attendance check should be like your final capstone of the day, saying that you've completed everything, you're ready to go, you've asked all your questions, and then you do this one question to type in your answer to make sure you understood today's lesson. Thanks for being so flexible, and we'll talk soon.